So here we're going to look at the parts of the quadratic function, and this is graphically, remember. Okay. So we have looked at y-intercept in the past, but it's usually the first thing that we usually talk about. So the y-intercept is where we cross on the y-axis, right? So it's where our function, remember, is this f of x, which is sometimes stated as y equals f of x. So it's along this curve, right? Because this will give us something like x squared plus blah, blah, blah. Something in the form of ax squared plus bx plus c, right? So it's where this curve intersects with our y-axis. So we know that this is right here. And so we can say that our y-intercept, in this sense, would be at negative or 0 on the x and negative 3.5. So we can give it in terms of our coordinate. Now, let's look at the roots. So, our roots, what are our roots or solutions? Well, the roots or solutions to our function is along this curve where we actually intersect with our x-axis. So far, we had to find where it intersects with our x and our y. So that's pretty easy. Now, I'm just going to erase those marks a little bit so I can actually read. So anytime you want to give these, make sure you give the full coordinates. So negative 3 and 0 and 6 and 0. Sometimes these will be represented as x equals negative 3, comma, x equals 6. Other times you might have seen them like this: x plus 3, x minus 6 equals 0. So either having negative 3 or positive 6 in there will give us 0. And that actually would be the equation. Knowing that, that would actually help us get our equation of our line, because we know that it's x squared minus 3x minus 18 is equal to 0. So that's because that tells us where our roots are. But yeah, we're not doing it by equations. So turning points then. Our turning point, well, it is basically saying our line of symmetry. Okay, this is our line of symmetry because these are symmetrical things, parabolas, right? Our curve is a parabola for a quadratic. So that means, where do we have a mirror of itself? Well, one thing that's actually pretty handy, and we'll go through this a little bit, is that when we have negative 3 and positive 6, so our roots, if we find the midpoint between those, that's where our line of symmetry will be. So in between 6 and negative 3, right? So we could do it on a number line for those of you that aren't really confident. So we could do negative 3, 5, 4, 3, 2, 1, 0, negative 1, negative 2. And then just cancel it 1 on each side till we find our middle, right? It's a great way of finding the midpoint. So it's 1.5, it looks like, which actually, if you look on our graph, you can actually see that graphically. And that's going to be the point, is that you want to be able to do this graphically, but I also want to always show how you can get these. So our turning point then would be at the point, well, we'd need to pick out the y value. So our actual turning point, it's not the line of symmetry, right? It's that maximum or minimum point. So this happens to happen at 1.5, and then we have to pick out our y value. Okay, so that's why it's often if you have the roots, use them. It's beneficial.